Alright, lesson 7.6, we're going to continue our work with graphs, and we're going to deal with the slope of a line. So two things we want to be able to do after this is to find the slope of the line, of a line when it's given to us, and then to use the slope to understand and draw graphs. So now, first of all, when we're dealing with slope, we have to deal with a couple of concepts. The first concept is what we call rise, okay? And the rise is the difference of the y values, and this is vertical, of 2 points on a line. And when we're talking about rise, let me use blue here. We are talking about, if I pick 2 points on a line, we are talking about the distance, the vertical distance from one point to another, okay? So in this particular case, we're talking about the vertical change from this point up to this point, again, in a vertical direction, okay? So how far up do we go, or down, because we could be going down. How far up or down are we going from one point to the other? And now this thing about y values, you know your y values in your ordered pairs determine up or down, okay? If you think about this point right here, this point is the point 1, 2. So 1, 2 is my ordered pair here, and for that particular point. This point over here is 6, 8. Okay, well, it's the y value, it's the second number, the 8 and the 2, that determine up and down. So the difference of those values, you'll notice here, 8 minus 2 is 6. Now, if we count this up, 1, 2, 3, 4, 5, 6, you'll notice that the vertical distance from this point to the next point, again, up and down, is 6. Okay, that is your rise. To get from this point to that point vertically, up and down, is a change of 6. So the rise is that vertical distance from one point to another. But then we get to the run, okay? And run is the difference in the y values, and you'll notice here I'm using the same 2 points. Okay, this point here, again, was 6, 8. This point down here was 1, 2. And it's the x values, in this case, let's see if I can draw my little bracket here. It's the x values that determine horizontally how far apart these two points are. Because if I take my 6, that's my x-coordinate of the second one, and I subtract my 1, that's my x-coordinate of the first one. 6 minus 1 is 5. And you'll notice if I count this out, they are 1, 2, 3, 4, 5 units apart horizontally. So that difference in x values calculates my run. And the reason we talk about this rise and run concept is when we get to slope. Okay? Slope is the constant rate of change of a line. Okay? And in other words, if you want to, you could write this down as steepness. How steep is a line? Okay? And it's found by the ratio fraction of rise to run. And this is rise over run. So if I want to figure out how steep a line is, and right now I'm going to focus on this part right here, although the change in y and over the change in x you should recognize from the last section. We're going to focus at least right now with this right here, rise over run. Slope is the relationship of rise over run, rise divided by run. And I'm going to show you how to do that here in a second, or right now. So we're going to find the slope of a line, okay? So the first thing that we need to do is we're going to identify 2 points that fall on the line, okay? So here is I'm going to use that point right there because it's pretty obvious in this case that that's the point 5, 5. And I'm going to use this point right here. Any 2 points on the line. And when I do so, again, it's rise over run. So the question that we have here, and in this case, because it's on a graph, you can go ahead and just count it out. Okay? How far apart vertically are the 2 points? Well, you'll notice it goes up 1, 2, 3, 4 units. Okay, so my rise is 4. We change colors here. I'm going to use red for my run. Okay, so that 4 is the vertical distance, the vertical change. My run in this case, you'll notice again horizontally is 1, 2. All right, so rise over run. Well, 4 divided by 2 is 2. So my slope in this case is a slope of 2. And what that tells me, for every 1 unit I move to the right, the line goes up 2 units. Notice that. Look at that. Because this would be 2 over 1, right? So for a run of 1, I have a rise of 2. To the right 1, up 2. To the right 1, up 2. And we can actually do slopes by using or do graphs, sorry, by using our slope if we know that rise over run relationship. Okay. But then we're going to move on, because that usually is pretty quick for most people to understand. How do we calculate the slope if we only have ordered pairs? Okay, so we don't actually, in this case, if I go back to the previous slide, we could find the slope because we can count it out on a graph. But what if we don't have a graph? What if we just have the ordered pairs? Well, in this particular case, then, we're going to use a little formula. Now, you remember, in our slope formula, it was rise over run. Again, the rise in ordered pairs are affected by the y values. The run are the x values. So what we're going to do here is we're going to take these points over here, and I'm going to just label these from left to right. I'm going to call this x1. This is my first x value. 7 is going to be my y1. That's my first y value. Again, xy. My second x value, in this case, is 9. I'm just labeling it as all I'm doing. So this is my second x value. 1 will be my y2. That's just my second y value. And I just go from left to right. So these become my x1 and y1, my x2 and y2, because they happen to come second. And so what I'm going to do is I'm going to take these 4 numbers and I'm going to put them into the formula. So my y2, my second y value is a 1, minus my first y value, which is a 7, over my second x value, which is a 9, minus my first x value, which is a 1. 1 minus 7 is negative 6. 9 minus 1 is 8. Now this will reduce. And this is, if I cut that in half, that's 3. And this is 4. And so I have a slope of negative 3/4. So what this is telling me is on my graph, if I start at, and I'm just going to say this is a point on the graph. Okay? It can be any point on the graph. To get to the next point on the graph, I'm being told that I want to go down 3 units. So I would go down 3, and I would go, my run is 4, I would go to the right 4 units, and my next dot would be 3 down and 4 to the left, or to the right. And from this one, my next dot would be 3 units down and 4 to the right. And so if having this rise over run relationship, I could actually, on a graph, plot one point, plot the next point, plot the next point, and so on, just by going down 3 and over 4 each time. And my line would actually run through, let's see if I can draw a straight line today, would actually run through those points, if I had it on a graph. But in this case, I don't have it on a graph, so, but I could, if I wanted to put it on a coordinate point. Okay, so now we're going to go ahead and we're going to use a physical science experiment or application. So in this particular case, what we have is the water that goes through the Hoover Dam every few seconds. So after 5 seconds, 75,000 gallons of water, cubic meters of water is released through the dam. So I'm going to go ahead, so 75,000 would be right about there. I'm going to plot them. 10 is 150,000 gallons released through the dam. At 15 seconds, we have 225,000 cubic meters. I keep saying gallons. I'm just used to gallons. And then 20 is 300 cubic meters. All right. So we have those, and you'll notice here we have a straight line going on. So the next part of this, though, is find the slope of the line and then explain what it tells us. So what I'm going to do is I'm going to pick any two values on the line. It doesn't matter which two. So I'm going to use this one and this one. Okay, I'm just going to use the first two. All right. Now my y2, and again in this case would be, instead of x and y, this would be my x and this would be my y. Okay, well, we would be using s and m. All right, but so we're going to go through and we're going to first set up our y values. So my second y value is 150,000. Minus my first y value, or in this case m value, is 75,000. Over my second x value, which is a 10, minus my first x value, or s value, which is a 5. And I'm going to go ahead and first do the subtraction. Well, 150,000 divided by 75,000 is 75,000. Alright, so 75,000 over 10 minus 5. Well, 10 minus 5 is 5. Alright, but then we're going to go ahead and we're going to divide the 75,000 by 5. 75,000 divided by 5, which is 15,000. And in this, okay, so 15,000. So the question in this case is, well, what does that mean? What does 15,000 mean? Well, this would actually be 15,000 over 1. Remember, this is cubic meters. Cubic meters, so that would be a 3 over seconds. So what that is telling me now that I've broken it down for 1 unit is they are releasing 15,000 cubic meters of water each second. Okay, so we're taking this this amount of water that's going through the dam every few seconds and figuring out how much goes out every second. So 15,000 cubic meters of water is released through the dam every single second. And that's what our slope is. We're breaking it down, how much in this case per second. Now the last thing to talk about is what type of line do we have when we have positive slopes, negative slopes, and so on. Okay, so I'm going to put lines here on these graphs. So I have my x-axis, I have my y-axis. A line that has positive slope goes upwards as it goes to the right. So in this particular case, and I'm going to change my properties here so that I actually have, and I'm going to change this to a red line. Okay, so if the line goes up as it goes to the right, it has positive slope. I'm going to clone this. A negative slope line is the opposite. It is a line that goes downwards as it goes to the right. Okay, because we read from left to right. So as the line goes to the right, it's moving downwards, so it has negative slope. Okay. Again, if the line is going upwards as it goes to the right, it has positive slope. Now I'm going to clone this line again, so I have a little red line. Zero slope is a horizontal line. Okay, and it can be anywhere. Okay, on the graph. Okay, but a horizontal line, because it's not going up or down as it goes to the right, it's just flat. This would have zero slope. And let me clone that line again and take it over here. A slope that is undefined is a vertical line. And the reason we call it undefined, if you think about our rise over run relationship, remember slope is rise over run, we have two issues. The question here is, if we pick any 2 points on this line, okay, we could have a rise, for example, from there to there. Let's say it's 8, okay, which is fine. We have a rise of 8. The problem is you don't have a run, okay, because remember, run is that horizontal distance. Well, we don't have a run, and we are not allowed to divide by 8, therefore, divide by 0, therefore undefined. That's the end.